So we've looked at rational expressions. Now let's look at this in the form of an equation, meaning that we're going to have something equal to something, right? And we're going to be solving for a variable. So let's learn through example. Let's look at negative 4x over x minus 1 plus 4 over x plus 1 equals negative 8 over x squared minus 1. So we ultimately want to solve for x. It's a little bit tricky here. A good first step would be to condense the left side into one expression, right? So we can get a common denominator. And luckily, that's going to end up being the same denominator that we have on the right side in this case, right? Because the common denominator here will be x plus 1, x minus 1, which is what this one will be factored. So let's go ahead and write that out. So we have x plus 1 over x plus 1 times negative 4x over x minus 1 plus 4 over x plus 1 times x minus 1 over x minus 1 equals negative 8 over, let's just go ahead and factor this just so it's all uniform. Okay. So now we'll go ahead and do the multiplication. So we have negative 4x squared minus 4x plus 4x minus 4 all over x plus 1, x minus 1. Okay, so I kind of did the addition and the individual multiplications all in one step here. So this actually, some things cancel out, right? We have the minus 4x and the plus 4x canceling out. We also have something that's going to factor here. So let me rewrite the whole thing, I guess. So this, the top now, we have negative 4x squared minus 4. So we can pull a negative 4 out of that, and we'll get x squared plus 1. Now, it's not very helpful, right? We can factor that out, but this isn't factorable. So it's just kind of a cleaner way to write it. Nothing more. Okay, x plus 1. X minus 1 over x plus 1, x minus 1. So now there's two ways we could look at this. We can either think, okay, these are two rational expressions being equal to each other. Their denominator is the same thing. So if these are equal and their denominators are already equal, then their numerators must be equal, right? Or we could just think of this as, okay, multiply both sides by x plus 1, x minus 1, x plus 1, x minus 1, and these cancel out, right? So either way you look at it, you're just going to be left with the numerator here on both sides. Now you could have done this right away. You could have, I wanted to kind of do it the longer way, but if you recognize right away that the common denominator over here was x plus 1, x minus 1, like that this factored is x plus 1, x minus 1, you could have just multiplied both sides by x plus 1, x minus 1, and just kind of canceled the factors along the way. But you would ultimately end up in the same place here. So now we'll divide both sides by negative 4. And we'll get x squared plus 1 equals 2. So x squared equals 1. And this means that x equals plus or minus the square root of 1. In other words, plus or minus 1. Right? So x equals 1 or x equals negative 1. Now, in any problem where we have a domain issue, we need to go back and check, can this even work, right? Is this even a possible solution? And in this case, the answer is going to be no, right? Because if we go back and plug in 1, then this denominator is going to be 0, and this one. If we plug in -1, then this denominator is going to be 0, and this one. So in this case, 1 and -1 are both outside the domain, and neither work. So in this case, we're just going to have no solution. Okay, so we have to take the domain into account on these. Go ahead and do another one. So 3x plus 2 over x minus 2 plus 1 over x equals -2 over x squared minus 2x. Okay. So let's do it the other way I was mentioning, which is that you can just right away multiply both sides by the common denominator. In this case, that being the x minus 2 times x. So if we go ahead and do that, if we multiply both sides by x minus 2 times x, and we can just write it like this, maybe good to put brackets around this because you're multiplying the entire thing, not just one of the terms. So the reason we do this is because now these cancel out, right? X times x minus 2 is x squared minus 2x. So those cancel. Now on this side, the x minus 2's cancel out for the first one. So we're left with x times 3x plus 2. And on the second one, the x's cancel out. So we're left with 1 times x minus 2. In other words, just x minus 2. And on the right side, we just have -2. So it's equivalent to how we did in the last problem. It's just doing the steps in a different order. So here we'll get 3x squared plus 2x plus x minus 2 equals -2. So now we're going to have a quadratic here. So we should go ahead and get everything to one side. Actually, the -2 and -2's cancel, so this is just going to be 0. Right, but with the quadratics in general, you want to try to get everything to one side and then factor. Right, otherwise we can't really isolate the x. So here we can actually go ahead and divide both sides by 3 since that's a common factor, just to make it a little easier. Okay, it's kind of an optional step there. And now we factor an x out, and we get x times x plus 1 equals 0. So we get x equals 0 or x equals -1 because of x plus 1 equaling 0. Okay. So again, we want to check our domain, and I believe x equals 0 is not going to work here, right? Because of the 1 over x term and the right-hand term as well. We can't have x equals 0 in either of those. But the x equals -1 does work in this case. There's nothing preventing that one from working. So we do have a solution, but not that one. So just x equals -1 would be our solution for this one.